In part 3 of the chapter 2 lecture describing motion, I'm going to discuss velocity, speed, and acceleration. First, let's start with speed. Speed is a scalar quantity which only has magnitude, and it tells us how fast an object is moving, but it does not tell us the direction of motion. So speed is defined as the distance traveled divided by the elapsed time. Here I also want to make a note that oftentimes you would hear the term average speed. That is the same as speed. So average speed is the same thing as speed. So I use the term speed because it's fast, it's faster to say, less letters to write, and so on and so forth. So that's what I will refer to when I'm talking about average speed. Simply speed. Okay. So the relationship that defines speed is dividing the distance traveled by the elapsed time, the time it took to travel that distance. In a formula form, this relationship looks like so. The speed v is equal to the distance d divided by the time t. So v is the speed, d is distance traveled, and t is the elapsed time. What are the units for speed? The units for speed would be the units of distance divided by the units of time. So there are several possibilities for acceptable units for speed. The base unit will be meters per second. However, for larger distances of travel, a typical unit is a kilometers per hour. So the speed is either given in meters per second or kilometers per hour in the metric system. Let's do an example problem calculating the speed of a moving object. A car traveled 80 kilometers in 120 minutes. What was the speed of that car in kilometers per hour and also in meters per second? So the definition of speed is the distance traveled divided by the time of travel. So what we know in this problem is the distance traveled, d, which is 80 kilometers, and the time of travel, t, which is 120 minutes. And what I want to calculate is the speed of the car. So I know that the relationship that calculates speed, or the formula, is v is equal to the distance divided by time. However, they ask me to find the speed in kilometers per hour first and then meters per second. The time here I have in minutes, which means that I cannot directly substitute in the formula and calculate the result. I first must convert the time from minutes to hours. This is very straightforward, because 120 minutes is just 2 hours. And so now I can calculate the speed. So the speed will be equal to 80 kilometers divided by 2 hours, or that is 40 kilometers per hour. Now let's calculate the speed in meters per second. So to do that, let's remember that 1 kilometer has 1,000 meters, and 1 hour has 3,600 seconds. So I'll use those two relationships to create two conversion factors, one to convert from kilometers to meters, and the other one to convert from hours to seconds. And so 40 kilometers per hour, I will multiply by 1,000 meters divided by 1 kilometer, and I will also multiply by 1 hour divided by 3,600 seconds. So the units of kilometers cancel out, the units of hours cancel out, and the units that are left are meters and seconds. And so now I have 40 times 1,000 divided by 3,600 meters per second. And this is equal to 11.1 meters per second. So when calculating any type of problem in the course, it is very important to pay attention to what quantities are provided in the problem and what you're looking for. Then you need to make sure that the units of the provided quantities are the correct units to get the units of the answer accordingly. In this particular example, kilometers per hour and then meters per second. If you have to do conversions, you can do the conversions before the calculation. If you want to do conversions after the calculations, you must be careful with that conversion so that you do not get the wrong answer. I personally advise that you always do the conversions before the calculation, just like we did here, and then go from there. Let's now discuss average velocity, or simply velocity. Velocity is a vector quantity which has a magnitude equal to the speed of motion, but also a direction. Velocity is a vector quantity calculated as the ratio of the displacement and the time of travel. So velocity is equal to the displacement divided by the time of travel. Notice that the definition of velocity is very different than the definition of speed. Speed was defined as distance traveled divided by elapsed time. Displacement is velocity is defined as displacement divided by time of travel, or elapsed time. So those are two different definitions. Distance is simply the length of path between 2 points in space, initial and final position. Displacement is the straight line distance between those initial and final positions in space as the object is moving. However, the units of velocity and speed are the same. So the units here would be kilometers per hour or meters per second, depending on the problem you're dealing with. So those are the standard units in the metric system. Since the displacement is defined as the straight line distance between final and initial positions, I can write the displacement as final position minus initial position. And we used that definition in the examples that I've calculated the displacement of the runner and the dog. So then I can rewrite the definition of velocity as velocity is equal to final position minus initial position divided by elapsed time, or time of travel. As you can see, this definition is much more deeper, detailed, and nuanced compared to the definition of speed. Most of the time in this course, however, we are going to deal with speed, so all we will need to really know would be the distance traveled and the elapsed time. Let's do an example problem calculating speed and velocity. A car drove from town A to town B, which are 120 kilometers apart, in 2 hours. So then the car turned around and drove to town C, which is 30 kilometers from town B, and the car did that in 1 hour. What is the car's speed for the entire trip and the velocity? So let's sketch the problem. So the car starts from town A, drives to town B. So this distance is 120 kilometers, and the time it took to get there, let's call this time T1, 2 hours. So then the car went from A to B, then the car turned around and drove to town C, right here, which is 30 kilometers from B, and it took the car time T2, which is equal to 1 hour to get from B to C. So the car went that way from B to C. So first we want to find the speed of the car. So first let's list what we know. We know the distance between A and B, towns A and B, that's 120 kilometers. We know the distance between towns B and C, that is 30 kilometers. And then we know the time it took the car to travel between A and B, that is 2 hours. And the time for the car to travel between B and C, that is 1 hour. So speed is calculated as distance traveled divided by elapsed time. So what is the distance traveled here? The distance traveled is the distance from A to B and then from B to C. So that would be DAB plus DBC divided by the time of travel, which would be 2 hours between A and B, and then 1 more hour between B and C. So that would be T1 plus T2. So substituting the values here, that is 120 kilometers plus 30 kilometers divided by 2 hours plus 1 hour, or this is 150 kilometers divided by 3 hours. So the speed V is equal to 50 kilometers per hour. So this is the speed of the car. For the velocity, the calculation is different because the velocity is calculated as the displacement divided by the elapsed time. What is the displacement here? The displacement is the straight line distance from the initial position to the final position. So the car starts from town A and stops at town C, or in town C. So the displacement is 120 minus 30, that is equal to 90 kilometers. That is the displacement. The displacement is simply the distance between towns A and C, that is 90 kilometers. So then the velocity is the ratio of the displacement versus the elapsed time. And so that would be 90 kilometers. And the elapsed time is still 3 hours. That is the total time it took to get from A to C. So that is 2 hours between A and B plus another hour between B and C. And so this gives us 30 kilometers per hour. So this is the velocity, and the speed is 50 kilometers per hour. The last quantity associated with motion of objects is acceleration. Acceleration is simply defined as the time rate of change of velocity. So acceleration is the time rate of change of velocity. Notice that the definition involves velocity and not speed. So if I want to write this as a relationship, that would look like so. Acceleration is equal to change in velocity divided by elapsed time. The acceleration is labeled with the letter A, and the units for acceleration are the units for velocity, which are meters per second, divided by the unit of time, which is seconds, or this is also written as meters per second squared. Meters per second to the second power. In a formula form, acceleration is written as the acceleration A is equal to a final velocity minus initial velocity divided by elapsed time, where A is the acceleration, V final or V sub F is final velocity, V sub I is initial velocity, and T is the elapsed time. Let's give an example to explain this formula here for the acceleration. A car travels with 10 meters per second when it begins to accelerate. After 5 seconds, the velocity of the car was 20 meters per second. Find the acceleration of the car. So I'm going to make a sketch of this problem and put all the variables on the sketch so that it's easier to follow what is happening. So here is the road, straight, flat, horizontal road. And so I'm going to look at the motion of the car at 2 points along the road. The first point is what I'm going to call the initial position. Initial position. So the car is right here. And the car has initial velocity V sub I of 10 meters per second. Then the car is accelerating, so some acceleration which we want to find is applied to the car. And after some time, t equal to 5 seconds, the car is at a different point of the road, which I'm going to call final position. And so here the car has different velocity because it accelerated. And so this is what I'm going to call the final velocity, and that is 20 meters per second. So I want to find the acceleration. Well, I know that the acceleration was defined as the change in velocity. So what is the change in velocity here? Well, this is simply the difference between the final value and the initial value of the velocity. So V sub F minus V sub I. So this is 20 meters per second minus 10 meters per second. This is equal to 10 meters per second. And so the acceleration is equal to the change in velocity V sub F minus V sub I divided by the elapsed time. So this is 20 meters per second minus 10 meters per second divided by 5 seconds. So this is 10 meters per second divided by 5 seconds, or this is equal to 2 meters per second, or in other words, that's 2 meters per second squared. So what is the meaning of this value of the acceleration? It means that the velocity changes by 2 meters per second every second. That is the time rate of change of velocity. Again, 2 meters per second every second. That means that initially the car was going at 10 meters per second. 1 second later, the car was going 2 meters per second faster. So that means 12 meters per second. After another second, 2 meters per second faster than before. So that is 14 meters per second. After another second, 2 meters per second faster than before. So that is 16 meters per second. And so on and so forth. So every second, the car would go 2 meters per second faster. And so that is the meaning of the acceleration. The acceleration is defined through the change in velocity. And so velocity is a vector quantity. Therefore, acceleration is also a vector quantity. So this means that when acceleration is applied to a moving object, this object can speed up if the acceleration points in the same direction as the direction in which the object is moving, or slow down if the acceleration points in a direction opposite to the direction in which the object is moving. A simple example of those two situations would be a moving car, and if the car, as it's moving, the driver pushes on the gas pedal, will cause the car to speed up. So then that means that acceleration was applied to the car in the same direction as the direction of motion of the car. However, if the brake was pressed, then the car would be slowing down, which is the same as acceleration applied in direction opposite to the direction of motion of the car. So, to generalize, when the acceleration has the same direction as the velocity of the moving object, the velocity increases. When the acceleration has opposite direction to the velocity of the moving object, the velocity decreases. One more time, if acceleration and velocity point in the same direction, then the velocity increases. And if acceleration and velocity point in opposite directions, then the velocity will decrease. Acceleration is a very important quantity because it is not only used in describing the motion of objects, but it is also used in explaining why objects move in a certain way, because acceleration is related to the applied force on an object. We are going to discuss the relationship between force and acceleration in the next chapter, which is about describing motion.